Hello, my name is Amanda Vandenhoevel and I am from Physics Today, and I'm going to be talking about some physics concepts and how it interacts with your daily life. So first we're going to talk about the scientific method. The scientific method starts with asking a question, doing some background research, constructing a hypothesis, testing your hypothesis, drawing your conclusion, and then reporting your results. What did you find? What was right? What was wrong? So there's actually a story about this that is about the Yangtze River and how it is creating sand dunes. This is actually a river in China, and it creates sand dunes. They're trying to figure out how this happened because it was flat 16 years ago. So that's kind of what they observed. They then saw there was this problem of a bunch of sand dunes. How did they get there? So the scientists believed that the sediment motion and flow of the river is what's creating this. He tests this. He put different things at the bottom of the riverbed to kind of figure out what was wrong. And sure enough, it was this flow and current is dragging the sediment, and then it's getting to a resting point. And so they are trying to figure out a way to make sure that this doesn't get out of hand. And that's kind of what they found with this sand dune. So there is issues like this that scientists are using the scientific method all of the time. Next, we have Newton's first law. So something that I do on a daily basis is I drive a car. I'm a nanny, I drive a car. This is my lovely 2005 Ford Explorer that I faithfully drive. It's paid off, hey, great. So I drive this and it gets me from point A to point B. And so this brings in Newton's first law because it is called the inertia law. And this means that an object that will stay at rest unless a compelling force is impressed on it. So when you turn your key to your ignition and start your vehicle, something's starting, so you're making a compelling force to get it started, and then when you hit the gas, it's another compelling force to get it moving. So that's just something that I use every day. Is I drive a car, and that's a physics principle. This one was really interesting to me. So I am someone who enjoys taking photographs, and I learned that James Clerk Maxwell is a physicist, and he figured out the first color photograph and how to make it. And so this actually shows you a little bit. There is 3 filters. There's red, green, and blue filters. And so black and white pictures is what used to be made. And when you put those all together, you can't really see it here. I'll zoom in a little bit. A color picture is created. And so that was just amazing to me that that's how it's created, and a physicist put that together. So I mean, how many people take pictures on their phone every day, and that's what you come up with? And this is actually like the 3 colors that our eyes see. It's when it's layered together that we get that complete picture. So that was just super cool to me that's how that was done. Einstein's theory of relativity is the next thing I'm going to talk about. So Isaac Newton believed that space and time were fixed and unmoving, but Einstein figured out that special and general relativity is fluid and always changing. There are 2 parts to this concept. The first is that an object that is moving at a constant speed and in a straight line, the law of physics is the same for everybody. The second part of this theory is that light travels at 186,000 miles per second, and no matter how fast or slow the observer is moving, the light still travels at that same speed, which I think is pretty cool. And so how this kind of works in your daily life, or how we see it, is when you're driving a car and you're going the same speed, it's a straight line, there's no bumps, you will be able to pour juice in a cup and it won't spill. It's unchanging. which this is something that if I'm in the passenger seat, I'm a nanny. And so I am busy and pouring juice in sippy cups to make somebody happy in the back seat. So this is something that I use on a daily basis. Not really a daily basis, but I use it quite a bit. Next is quantum mechanics. This one, wow. I started this class and I thought, physics, how boring. I learned all about this and I'm like, oh my gosh, I use this stuff all the time. So cool. So quantum mechanics, something that is used with quantum mechanics is a GPS, which is a global positioning system. And this is where a network of satellites figures out where you are, and they determine the distance from each of them to figure out where you are and how to get you to your next place. I know that I'm very dependent on my GPS. If I'm in a place that I'm not familiar with, I am going to pull out my GPS on my phone to figure out how to get where I want to go. So that's just something that I think our society really uses quite a bit of. Kind of a backstory, which I thought was crazy, was I was with my sister's mother-in-law, and there was a map. We were at an event, and there was a map. It was kind of downtown in this big town, and she didn't know how to read the map. She didn't know how to get from point A to point B because she's always used her GPS on her phone, which I thought was just crazy. So I read the map. But anyways, that was the backstory. Also, quantum mechanics that's what's used in an MRI. So this is a picture of an MRI machine. And what happens in an MRI is things flip and spin nuclei of hydrogen atoms, and this creates a magnetic field so that the radiologist, which is a doctor, can measure the concentration of hydrogen in different parts of the body. So an MRI is able to show you more softer tissues, where an X-ray is your bones and your harder tissues. So I actually have had quite a few MRIs in my lifetime. I had a knee injury where I tore my meniscus. That's actually the padding in between your bones, your joint. And I tore that. And so the only way to see how bad it was and if it would heal on its own or if I needed surgery was to get an MRI. And so sure enough, I did need surgery. Unfortunately, it didn't fix the problem. I tore it again, and there's really nothing that you can do because you can only take away so much meniscus. But anyways, that's another thing of physics that, our medical industry, we use so much physics and don't even think about it. So that is what I have for you today. I hope you learned something, and I hope you have a great day. I'll just finish it out with my references.